Am I audible? Those who are those who are watching this session, please respond in chat. Am I audible? Am I audible? Okay, done. So, hello everybody. Welcome to iitiansgateclasses. So, we are discussing previous year's paper solution for GATE Aerospace Engineering, and today I'll be starting with GATE 2018 for mechanical vibration part. So there are total 3 questions they asked in GATE 2018 paper, and it is for not three. There are, yes, 3 questions, and it is for 4 marks. Okay, and GATE 2018 paper was one of the easiest paper. Okay, for GATE Aerospace Engineering in most of the years. Okay, so read this question. What it says: for a damped single degree of freedom system with damping ratio of 0.1, damping ratio of 0.1, the ratio of two successive peak amplitudes of free vibration is. So guys, I think similar question was there in last session also, right? So they have given what damping ratio zeta, which is given as 0.1 here, and we know guys logarithmic decay, right? Delta is nothing but what? It is ln of ratio of two successive amplitude, right? Clear? Now guys, what is delta? Delta is approximately equal to 2 pi zeta, right? Now what is asked? They asked the ratio of two successive amplitude, right? So x1 by x2 will be what? E power 2 pi zeta. E power 2 pi zeta, guys. Find out x1 by x2. They asked guys in two decimal place. Quickly guys, find out. So what is x1 by x2? x1 by x2 will be coming as how much? 1.88. Yeah, it is 1.87 or 1.88. So it's a repetitive question. Okay, and it was very easy question. It was an easy question. So read next question. So this is a bit confusing question for many students. So first, see this question and tell me it's a 2 degree of freedom system question or 1 degree. Read the question what it says. The natural frequency of the spring mass system shown in the figure below is. So now guys, first tell me it's a 2 degree of freedom system or 1 degree of freedom system. Ashish, Amit. Those who are watching this session, please respond. It's a 2 degree of freedom system or something else. It's a 1 degree. Why, Amit, it is 1 degree of freedom? See, in this question, they have given this K1 20, K2 20, right? So what about this K3? What is K3 value? For rigid link, what is the K value? What is the stiffness for rigid link? So for rigid link, K3 is infinite, right? So that means this mass M1 and M2 will move together, right? There will be no deformation in rigid link, right? So whatever displacement x1 suppose you apply here, this will also move by x1, right? So now you can see we need only 1 degree of freedom, right? Stiffness K is 0. Amit, it is infinite, not 0. For rigid link, stiffness will be infinite, so there is no deformation. Okay. So now you can see this is a single degree of freedom system, right? Because the rigid link will not have any deformation. So now tell me, if it's a single degree of freedom system, so this K1 and K2 connected with this whole system which has mass M1, M2 and rigid link, how? In series or parallel? Now this combination, which is in series or parallel? Just guys think swastik, it's series or parallel. See what will be M equivalent in this case? It will be M1 plus M2. So it is 6 plus 4 equal to 10 kg. Okay. Now what will be K equivalent? Yes, it is in parallel. So my K equivalent is what? K1 plus K2. So which is what? 20 plus 20. So it is 40 Newton per meter. Now, what is the natural frequency, guys? Because now, guys, you already know, right? What is the K equivalent, and you also know M equivalent. So it is what? K equivalent and it is M equivalent. So what will be the natural frequency? Omega n will be what? It is K equivalent upon M equivalent. What is the K equivalent? It is 40. And what is the M equivalent? It is 10. So what is the natural frequency? 2 radian per second. Right? So it is what? Omega n. Now guys, they asked answer in radian per second, right? Not in hertz, right? So this is what your answer. 2 radian per second. So what was the confusing situation here? It is rigid link. So this M equivalent we have to take, and then we have to solve this problem as a single degree of freedom system. Okay. So let's move to next question. What it says? Read question. A 1 meter long massless cantilever beam oscillates at 2 hertz. Okay, while a 60 kg mass is attached at the tip of it. The flexural rigidity of the beam is. Now, guys, what is the given case? There is one beam, okay, cantilever beam, and here it is massless, okay, and the entire mass is concentrated at what? Tip. So what is the mass at tip? It is known as 60 kg. Now guys, we already know for a cantilever beam, and if it is idealized, the total mass acting at free end or at tip, right? What is the natural frequency? Omega n. It will be under root k by m. And what is the k? In this case, we know what is the K. It is 3EI by L cube, right? 3EI by L cube. Okay. You guys can refer IGC formula sheets. There we have given different cases of beam when those are idealized as point masses. Okay. Now, guys, in this case, what is unknown? EI value is unknown, and omega n is given in terms of what? Hertz. So from here, what we have to do? We have to write in terms of hertz. So it will be what? 2 pi fn under root k by m. Now guys, substitute everything here. Substitute everything, guys. What you see? 2 pi into 2 will be equal to what? Under root. Now k, it is 3 ei by l cube. Length is how much? 1 meter. So it is what? 3 ei upon what is the mass? Mass is given as 60. Now what is unknown? Flexural rigidity. So what is the flexural rigidity for beam? EI is known as flexural rigidity. Now guys, everything is known. Find out EI. So what will be EI? EI will be 16 pi square 16 pi square into 60 divided by 3 will be equal to what? EI. Find out the value, guys. So 20 into 16 pi square. So EI will be what? 320 into pi square. Tell me the answer, guys. So here the answer will be in what? We are finding everything in Newton meter square. So this will be in what? Newton meter square, and they asked in kilo Newton meter square. So guys, do the calculation and tell me what is the answer. Ashish, Swastik. Yeah, so it is in kilo Newton meter square. The answer is how much? 3.158 kilo Newton meter square. Guys, based on this, previously also they have asked question specifically this cantilever beam, and it is idealized with what? A point mass at tip, right? So whenever cantilever beam is idealized with point mass at tip, first your k will be what? 3 ei by l cube, and your natural frequency omega n is what? It is under root 3 ei by m l cube. One more thing I want to tell you guys. In this case, what will be delta static for cantilever beam? What will be delta static? It will be what? Mg by k. Clear? It will be what? Mg, which is what? Weight by k value. Sometimes they may also ask, guys, what is delta static? So it is what? Mg, which is what? Weight by k. Clear? Everyone, is it clear? Yes or no? Is it clear, everyone? Yes or no? Okay. So let's move to next. So there were only 3 questions in 2018. Now we'll move to 2019 paper. So 2019 paper for mechanical vibration part, there are total three question, one question for 1 mark and another two question for 2 marks. So weightage is here 5 marks. Okay, so let's see the first question what it says. In the spring mass system shown in the figure, mass m equal to 3 kg and spring stiffness k equal to 20 kilonewton per meter. The natural frequency of the system they asked in hertz. So guys, here you need to convert radian per second to hertz. Before that guys, look into this system and tell it's a 1 degree of freedom or 2 degree of freedom system. Suppose this spring is first spring, second spring, and third spring. Now tell me guys, this spring 1 and 2 with respect to this mass are in parallel or series? And also this system is what, 2 degree of freedom or 1 degree of freedom? Hmm? You guys remember there was one question where there were two masses connected with only one spring. Tell me guys, that problem was 2 degree or 1 degree? Yes, this 1 and 2 are in series, right? So if you find k equivalent of this, what will be the k equivalent? It will be k into k upon k plus k. So it will be what? K by 2, right? Now this k equivalent of 1 and 2 with k3, how? Are in series or parallel? Asan, this k equivalent 1, 2 and this spring k3 are in series or parallel? So these are in parallel. So final your k equivalent will be what? It will be k by 2 plus k. So your k equivalent for all 1 to 3 is what? 3k by 2. Now what will be your omega and natural frequency? It will be k equivalent by m, and k equivalent is what? Here omega n you get 3k by 2, and what is the mass? The mass is given as 3 kg. So let's substitute in the next step. So it is 3. Now guys, k is given as how much? 20 kilonewton per meter. So guys, make sure you first convert it in newton per meter. So it is 20 into 10 to the power 3. 2 into mass is how much? 3 kg. Mass is 3 kg. So what is omega n coming? What is omega n will be coming? Omega n will be coming as how much? Hmm? What will be omega n coming? It will be coming as 100, right? It will be coming as what? 100. Now guys, we know omega n is what? It is 2 pi fn, right? Because here this is in what? Radian per second. Now what will be fn? Fn will be 100 by 2 pi, and it will be in what? Hertz. So find out guys, fn value. It will be approximately equal to what? 16 hertz. So they asked answer nearest integer. The nearest integer. So it will be 16 hertz. It will be some 15.9 something. So Fn is 16 hertz. Clear? Everybody, is it clear? Mr. Rahul, is it clear? Ashish, others? So, Hassan, you are non-IGC student, right? Yes, 15.92. So, how are our session? Are our sessions useful, Hassan? Yeah, 16 is correct answer. Yeah. So, let's see next question. What it says. For a damped For a damped spring mass system, mass m equal to 10 kg, stiffness k equal to 10 to the power 3 Newton per meter, damping coefficient c equal to 20 kg per second. The ratio of amplitude of oscillation of first cycle to that of fifth cycle is. Okay. So guys, they asked in this question, what they asked, the amplitude of first cycle. So they asked what? They asked x1 by x5, and you all know, right, we have done similar problem earlier also, right? But before that, in this problem they given c in terms of what? 20 kg per second. Now guys, first just verify. We know unit of C is what? Newton second per what? Meter. Now guys, just check it. What is the Newton? Newton is nothing but what? Kg meter per second square into meter into second. So what you see? Second got cancel, meter got cancel. So it is what? It is kg per second. Clear? So that means no issue with unit. We already know, guys, what is the zeta? Zeta is the ratio of damping coefficient upon critical damping coefficient C by Cc. So C is given. What is the Cc? It is 2 under root Km. Okay. Now, guys, C is 20 upon 2. What is the K value? K value is 10 to the power 3. What is the M value? 10. So what we find, guys? We'll get 20 by 20. So what is zeta? In this case, what is zeta? I think we will be getting 1, right? Just guys check it. 10 to the power 4. 10 to the power 4 is 100. No, no, not 1.1. It will be 20 by 200. 20 by 200. Guys, check it. 20 by 200. So we get zeta as zero point 0.1. Clear? Yeah. Now once you get zeta, we already know what is the logarithmic decay delta. So delta here, it will be what? What will be the n value here? What will be Ashish's n value here? It will be what? Nth amplitude minus first amplitude, right? So what is the nth amplitude? It is fifth. What is the first amplitude? 1. So what will be n value? What will be n value? Hassan, what will be n value? See, this is where people do mistake. They don't know how to calculate n value. So it is always nth amplitude minus first amplitude. So what is the nth amplitude? It is fifth amplitude. What is first amplitude? It is first, right? So it is 4. So what will be delta? So delta will be 1 by 4 ln of x1 by x5. Now, what is asked in the problem? They asked in problem this x1 by x5. So, guys, what will be x1 by x5? Before that, what is the delta? We know delta is always approximately equal to 2 pi zeta, right? See, uh, C is in our GATE syllabus. Usually, we have C value for viscous damping only. So, it is better we can say viscous damping coefficient. In case of Coulomb's damping, we have mu value, okay, friction coefficient. It's not C. And in other damping also like structural damping and all, okay. So there are different constant, but this mainly C value which we are using for damped vibration, it is for viscous damping only, okay. Clear? Recreation person. Okay. Now, guys, already delta is known here. So it is what? 1 by 4 ln of x1 by x5. And this is what? 2 pi zeta. So what will be x1 by x5? It will be e power 8 pi. And what is the zeta value? It is 0.1. So tell me, guys, this ratio x1 by x5, how much it is coming? So x1 by x5 is coming how much? 12.344. Now guys, many people do mistake in exam. When it is asked amplitude ratio, what they just find? They just find what? Delta, which is not correct. Okay? It is not, delta is not equal to what? X1 by x5. So you have to find correctly. So 12.344 is the answer. Okay. So this question was again easier question. Okay. So let's move to next question. What it says. Yeah. Correct answer. Rahul. Swastik. It's 12.3 something. So let's see this question. What it says. For the system of springs and masses shown below, K equal to 1250 Newton per meter and M equal to 10 kg, the highest natural frequency omega of the system is. So, guys, we all know, right? What is the natural frequency formula for 2 degree of freedom? They have already shown x1 and x2, and it's a 2 degree of freedom, right? So what is the frequency formula? Yeah, x first and upon x fifth. 12.48. Just check it. It is 12.4. Yeah, 12.42 around. Is this not correct? 12.344. See, it's a calculation e power zero point 0.8 pi. So that is how, don't write pi in terms of, value. In virtual calculator, you substitute pi as a pi value. Don't substitute like 22 by 7. Okay. So or you can say it is 12.4 around. Okay, so they will give answer in range, but your answer cannot be what your answer. Yeah. Now one more thing, Hassan. Your answer may have little variation due to what? We have approximated, right? It is what? 2 pi zeta. So, or if you want more accurate answer, it will be what? 8 pi zeta. Okay. So, zeta is how much? Zero point 0.1 upon under root 1 minus zero point 0.1 square. Okay. So, there may be further some variation. Okay, so that you guys can take care. Now look here, this is what 2 degree of freedom system. Now 2 degree of freedom system, so we know what is the natural frequency formula for 2 degree of freedom. You guys can also remember like me how I remember. It is always m1 into m2. It is what? m1 into m2 omega power 4 minus, then it is multiplied m1. m1 will be multiplied with what? k2 plus k3. Then m2 will be multiplied with what? It will be k1 plus k2, and outside it is what? Omega square. Then it is what? Plus k1 k2, then plus k2 k3, then plus k3 k1 equal to 0. Okay, now guys, in this problem, what is your m1? Equal to m2, and it is given how much? 10. And what is your k1? K1 is equal to k2 equal to k3. Okay, so substitute everything. So what you find? You find m square omega power 4 minus, so you get 4 km omega square. What you get? 2k plus 2k m, so 4 km into omega square. Then yeah, I understand, Hassan. So it is better to use a denominator also. Sometimes they may not give the answer which is done without using denominator. Okay, so then it will be plus 3k square equal to 0. Now substitute everything. What is the mass? Mass is 10. So it is 100 omega power 4 minus. What is the k and m? So it is 20, k is 1250, right? So 1250 into 4 into 1250 into 10 omega square plus 3. What is the k? 1250 square equal to 0. Okay. Now guys, so further what we see? We will find omega power 4 minus 500 omega square plus 3 into 125 square is equal to 0. Now guys, what will be omega square? It will be under root. Now b square, it is what? Minus b. So minus b means 500 minus b plus minus under root b square. So it is 500 square b square minus 4ac. So minus 4 into 3 into 125 square upon 2a. So it is 2. Now guys, they asked what highest natural frequency. So you use plus sign and tell me omega. Sorry, it is not omega square, it is omega. This is what omega. This is what omega. So we use Dharacharya's quadratic formula and we found it is what? Minus b plus minus under square b square minus 4ac upon 2a. Check it guys, is it correct? Yes or no? So what omega you will find? You will find one will be 25, another will be some 11.18. Just check it. Is it correct or not? Everybody please check it. Is this correct? Yes or no? So I think I have done x square. Here it is 4 km or 6 km. Just k2 plus k3 2, and this is also k1 plus k3. So 2 plus 2 4, right? Check it guys. Is it correct? Yes or no? Oh, okay. Not k1 is not equal to k2 3. Sorry. See here. K1 equal to K3 and K2 equal to 2K. Okay, guys, be careful. I've done this mistake. So it is 6 km. Okay, this is what 6. Okay, 6 km. So instead of 500, guys, please do this correction. Please do this correction. So what it is? It is 6 km. It is 6 into 12 50 into 10 omega square, and here you get 750. So basically basically here this is typo. Okay, so what it is? It is 750 plus minus, it is 750 square. Okay, and it won't be 3k square. So it will be how much? No, no, it will change for different. This equation is same. This is same for any 2 degree of freedom system given in this format. Okay. Now another here. Here will be also correction. So this will be how much? We have k1 into k2, so it is k square plus 2k square plus 2k square. So how much? 2 plus 2, 4 plus 5. So instead of 3, it will be how much? 5. And it will be 5. So this is also 5. Okay, sorry guys, be careful. I've written every equation correctly, but here your K2, your K2 is 2K. Here your K2 is what? 2K. So what is given? K1 equal to K3 and it is given as how much? K, and your K2 is what? 2K. Now this equation is correct, guys. This equation is correct, and find out root. Okay, so I think with this we get 25 comma 11.18, and they ask what? Highest natural frequency. So your omega answer will be 25. So guys, again yesterday I told I do lot of silly mistake, and in guys I want to share my story. I wrote gate in 2009, and guys I did one silly mistake in column problem. In column, when you find your P critical, what it is? It is pi square EI by L square. Now tell me guys here, what is the I value? It is the minimum or maximum? So I value should be always, in case of column P critical, when you find it should be I minimum. Okay, so guys, do this calculation and tell me. Swastik, are you there? Is it correct? Omega 25, if you solve this problem. So, or in a simplified form, if you write this equation, what it is, I have written previously, it is omega, omega power 4. Okay, so how can I write it in a simplified format? You can say it is omega power 4, then minus 750 omega square, then plus 78125 is equal to 0. Now guys, you can substitute always omega square equal to x. So what you find? X square minus 750x plus 78125 equal to 0. So the root of this equation, x values will be 625 comma 125. Okay, these will be root. So from here we'll find omega 1 will be 25 and omega 2 will be 11.18. That's the highest natural frequency, so it is 25. Clear? So 25 is the answer. Yeah, 5k square. I have substituted 1250 square. Now it is correct, right? Hassan, it is correct, right? This equation is correct, right? I have corrected my typo. So guys in hurry, don't do problem. Be careful when you substitute values. Okay, clear? Hassan, this equation is correct now. Okay, so 25 is the answer. 25 is the answer. See, this problem was not tough. The only thing we did silly mistake, or we did mistake, so that's why it took more time. Okay, so that's all in this paper. So let's move to next paper. It is gate 2020 paper, and in gate 2020 paper they asked again 3 questions, and these 3 questions are only for 5 marks. Okay, now read first question. What it says: the natural frequency the natural frequency of the first mode of rectangular cross-section cantilever aluminum beam is omega radian per second. If the material and cross-section remain same, but the length of the beam is doubled, the first natural frequency will become. So guys, in case of beam, we all know the natural frequency for a continuous beam is proportional to what? It is proportional to 1 upon L square under root EI by rho A. Now guys, they are keeping cross section same. So your A and I will not change. They are also keeping material is same. So your E and rho will not change. So your omega is proportional to what? L square. Now guys, they double the length. So they ask what will be the final frequency. So what will be your omega 2 by omega 1? It will be L1 by L2 square, right? Now guys, what is the omega 2? Omega 1 is what? Omega, and it is what? L1 is L, and then your length is 2L. So what will be? It is omega by 4. So what is the answer? What is the answer in this case, guys? The final natural frequency when length is doubled. What is the answer, Swastik? What is the answer? Hassan, is last question clear? Yes or no? Last question clear to you? Yes or no? Swastik, is this correct? What will be your omega 2? Omega 2 will be omega by 4. I didn't get, Hassan, what you are saying, Max. Okay, so for this, A is the answer. Question number 18. Let's move to why B is the answer. Why B is the answer, Swastik? They asked what is the frequency when length is double. So it's a omega 2, right? So it is omega by 4. Answer is omega by 4. Okay, so let's move to read the question, Swastik. Why omega 1? See, omega 1 is given already, right? It is omega. When omega 1 is what? When length is L. What is omega 2? When length is 2L. What is omega 1? It is given as omega. So what is omega 2 we got? We got omega by 4. Okay, fine. So let's move to next question, guys. Read the question what they say. Before that, any question? Yeah, this is done. Let's move to question number 51, what it says. A critically damped single degree of freedom spring mass damper system used in a door closing mechanism becomes over damped due to softening of the spring with extended use. If the new damping ratio zeta nu for overdamped condition is 1.2, the ratio of the original spring stiffness to the new spring stiffness K original to K new, assuming that other parameters remain unchanged, is. So guys, initially your system is what? Critically damped. Okay, initially system is what? Critically damped, right? The initially system is what? Critically damped, right? So for critically damped system, your CC, we know it is what? It is always 2 under root km, right? And K is what, guys? K is K original, right? And m is the mass. Now in the problem, everything remains same, but what is changing? Your K is changing. So your system became what? Overdamped. And we know, guys, what is zeta? Zeta is what? C by cc. Okay, C by cc. Okay, now guys, zeta they have given. Zeta is how much? 1.2. Okay, 1.2, and it is 1.2. Okay, and C upon C upon 2, it is C upon what? When zeta is 1.2, so it will be what? C upon 2m k nu, right? And guys, when zeta was 1, when zeta was 1, when zeta was 1, guys, when zeta was 1, right? What was your k? It was 2m k original. Clear? Now you can say this cc equal to 2 km k original. This is when zeta equal to 1. Okay, guys, they asked the ratio of what? K original by K new. So you can see, suppose this is equation 1 and this is equation 2. So if you divide 1 by 2, what you get? 1.2 will be equal to what? It will come as under root K original by K new, right? What was mistake? I didn't get Hassan. So what is asked in problem? K original by K new. So if you square it, you get K original upon K new. So it will be 1.2 square. So 1.2 square is how much? 1.44 is the answer. Okay. Now guys, understand this problem again. We know zeta, it is always C by Cc. When it is a critically damped system, your stiffness is K. When it became over damped, you have new stiffness. Your damping coefficient is not changing. The initial C value is not changing. Okay, your mass is not changing. Only changing is what? Stiffness. Clear? So this is how we need to solve this question. Clear? Yes or no? Everybody, is it clear? Yeah, Hassan, you are telling mistake. What it mean? So the last question. See the last question. What it says? Okay. Read the question. It's again a simple question from 2 degree of freedom. What it says? The two masses of the 2 degree of freedom system shown in the figure are given initial displacement 2 centimeter for mass m1 and 1.24 centimeter for mass m2. The system starts to vibrate in the first mode. What they ask? The first mode shape of this system is given by phi 1 equal to 1a transpose. So where a value. Now guys, the system is vibrating only in first mode. So you all know guys what your initial displacement of mass m1 x1 initial, we all know guys, I have written earlier, it is equal to what? It is x1 for first mode plus x1 for second mode. And what is the x2 initial displacement? It is x2 for first mode plus plus x2 for second mode. Now they given the system vibrate in first mode alone. So that means this is 0, this is 0. So from here what we found, x1 for first mode, what it is given? It is given as 2 centimeter. Okay, and what is your x2 for first mode? It will be 1.24. And we know what is the first mode. The first mode phi 1 will be what? X1 for first mode upon x2 for first mode. So it will be how much? 2 upon 1.24. So it will be what? It will be 1 upon 0.62. So this is already given. It is what? It is given as 1a. So what is the a value? If you compare this with this, what is the a value? It is 0.62. It is how much? 0.62. Clear? So guys, I'm in bit hurry. We have another session. Otherwise I would have given more information on this, how to solve. So they already mentioned the system vibrates in first mode. Suppose they have given the system is vibrating in second mode. So then your initial displacement x1 initial will be equal to what? It will be x1 for first mode plus x1 for second mode. So this will be 0. Now if same thing x2 initial, it will be what? It will be x2 for first mode plus x2 for second mode. Now if system vibrate only in second mode, this will be 0. Now if you find phi, what it will be? It will be phi 2, and phi 2 will be what? X1 for second mode upon x2 for second mode. So this is how you have to find second mode. Okay, so that's all from today's session. Thank you guys, thank you for watching this session. And I have completed all the mechanical vibration question from 2007 onward to 2023. You guys can find on our YouTube channel. The session for 2021, 2022 and 2023 are already available. So this year for that's all from my side. Thank you all. And if you guys like this session, if you find guys if this session was useful, you guys can thumbs up to this session. You guys can also subscribe to our YouTube channel and join our Telegram channel for further update. Okay, so thank you all the best guys.